Hi, I'm Bryan Brady. I'm the Senior Extension Associate at the Food Connection. I'm also a graduate student in Plant and Soil Sciences working on the baguette project. The part of the baguette project that I work on is evaluating modern cultivars that have been bred for the Southeast, and also some heirloom bred wheat cultivars that used to exist in this area around the 1900s. And what we're looking at is, we're evaluating them for agronomic qualities. We're also evaluating them for bread baking qualities, and then also flavor. Talking about bread baking quality, what does that mean? The difference between a bread flour and an all-purpose flour and a pastry flour is generally protein. Bread flours have higher protein. All-purpose flours kind of fall in the middle. Pastry flours and cake flours fall at the bottom. And a lot of that is cultural, like depending on where you live. If you were to separate states into which state would be a biscuit state, which state would be a bread state as far as culture is concerned, the South is mostly biscuit type wheat, and the Midwest is kind of bread flour area. But protein doesn't quite tell the whole story with bread baking quality. You can have, let's say, a good example is King Arthur AP flour is 11.7% protein, and the King Arthur bread flour is 12.7% protein, but they are astronomically different to work with. What the difference is the two proteins that go together to form gluten. One is glutenin, and one is gliadin. Now, gliadin provides the extensibility in a bread product, or in the dough, and glutenin provides the elasticity. And I'm going to show you an example right here. We've got King Arthur bread flour that's been mixed. This is just flour and water. And you'll see this has been what's called autolyse, which is basically just mixing together flour and water and letting it sit. This has not been kneaded at all. And we'll see kind of the extensibility of the dough. You see how it stretches and it doesn't tear. And it can actually form what we call a window pane here, where you can actually see some of the gluten strands in here. You can see how nicely that stretches and how nice and shiny it is and how easy it is to work with. And then we have a flour that was grown here in Kentucky that is a bread flour. And you will see quite a different story here. So as it starts to stretch, it tears. And this is partially due to this being higher protein, but in reality, you can get a lower protein flour and still make good bread out of it, still get good extensibility, still get good elasticity. The glutenin is what's really important. And so in the baguette project, we've had some of these flours. I've been working with 6 wheat varieties, 4 of which are modern, 2 of which are heirloom. And we've sent those off and we've had them tested. And this one would definitely test out on the high scale, where this one would test out on the low scale. So this is what we're looking for. This is definitely not what we're looking for, and the flours that we're getting here in Kentucky are kind of falling somewhere in the middle. Part of that is definitely due to the weather. We don't have the same weather that they have in the Great Plains during the grain fill stage, and a lot of times we end up with a lot more rain that affects the ability of the grain to take up nitrogen. And we end up with lower protein flours, even though we might be growing the same variety that they would be growing in the Midwest. Total protein content is something that we really can't compete with in Kentucky, given our weather. We have a lot of rain compared to places that produce really high protein flours. But the possibility exists that we can grow wheat that can produce flour that has a lot of high molecular weight glutenin in it. So even though the total protein numbers are coming in, between 10 and 11, somewhere in there, not what you would see with the typical bread flour, you're still getting that high quality glutenin that can produce really good bread.